So we are back from the break and ready to keep going. Please welcome Anil Kumar, software engineer at POA. He'll share with us how to go from queries to intelligence using JavaScript, SQL, and AI to build smarter systems. Anil, stage is yours.
Perfect. Thank you so much for the quick introduction. So starting with something about myself, I think I shall start with some stuff which I built. Do I believe? Open just a moment. Yeah, there you go. Sorry. I don't know if I'm sharing my screen. I think I do.
Yes, we can see it.
Perfect. Great. That's great. Great. So yeah, there you go. So myself, my name is Anil Kumar, and I work as a software engineer here in the UK in an EV tech startup company. So basically, what we do is we basically support the EV charging, infrastructure here in the United Kingdom. So basically, in there I work as a mainly backend software engineer, and here in this position, I mainly work on the APIs, working with the charge the data coming from the charge points and accumulated it and show some good stuff on the dashboard for my customers. So this is something I'm responsible for at my role, and yeah. So that is some quick introduction about myself, and let's go further. Sorry. Yeah. So number one is the highlights for today's agenda is basically what we will be doing today in introduction to intelligent analytics and low code. Not sure if everyone of us really know about the low code platform, and so definitely I'll go through with the low code platform very first in the next couple of slides. And then what we will be learning here in the overview of charging insight data, as I mentioned before, that I work for an EV tech startup, basically. So what we do is, the small business thing is basically we support a RFID charge card and with mobile application where you can go and charge any public charge points here in the United Kingdom, and you will get only one VAT receipt per month for all your charging sessions. And not only this, but you can have many more things in that. And number three, basically in this tutorial, what I will be showing is how AI interprets multi-JSON inputs. This is the main highlight of this tutorial, which we will be doing because that's very important, right? Because things are there, but we can interpret ourselves as well. But if we get some details, AI support, that's always amazing. So this is what we will be seeing. Number four is transforming raw data in executive level insights. Of course, data is of course everywhere. And what we as a software engineer, as a data scientist, as a tech persons, what we would like to see the data accuracy, data representation, and interpret the data. How does it look like, and any anomalies we found. So this is very important in today's world, and this is what we will be doing. And then we will be demoing the quick insights generation from the AI. And yeah, benefit from the future enhancement. Of course, we all know, and the main agenda of this conference is also the data science related and AI related things. So we will be doing, and we'll show that how things are getting changed and how the AI is revolutionized in the world. So, like I mentioned in this slide about the low code, here we will learn a brief about low code, what exactly it is. So, low code platform really, allows rapid application development using visual tools. Basically, here if I compare with the traditional programming and the low code, so I can say only one thing, which is low code is way faster than what we do in a traditional programming. And low code basically helps us to basically accelerate our projects, and definitely it helps us to uh, uh, complete our task, our goals relatively more quicker than what we do. So before we talk about, I mean, even out systems, which will be we will be talking about, but why low code exists here? Because business requirement changes weekly, maybe yeah, even daily, of course. So here, the problem is not the tech itself, but we have to change things rapidly, and we want definitely velocity in our development program. So this is where the low code really helps. One architecture, one database. You can build your APIs, integrations, everything you could even think of. And yeah, I mean, database schema, UI, validation, or error handling, everything in one platform. And since if I talk about the traditional programming, when we do a couple of things together, we have Git to basically version controlling. We have a separate way where we, publish our own versions, and the version controlling is happening in the low code effectively and very easily as well. So this is why low code is important. It reduces the manual coding definitely. Low code doesn't mean that you are, exempted from the code at all. It's not at all really. Some no code platform all also exists in the tech and the data and in the world. But yeah, low code is all about reducing the quality and increasing the velocity and the quality. This is what the low code is. So yeah, why out systems? So basically, in this world, we have a couple of big, major low-code platform available. OutSystem, one of them. We have Mendix as well. If anybody knows, it belongs to Siemens, I believe. So OutSystems, leading low-code platform where you can visually drag and drop the widgets, and from start to end, you can build your own things. Much faster than the traditional thing, basically. So that is the basic agenda of our today's tutorial, that we will be using OutSystems in our usually the tutorial. So it basically provides visual tools, think drop and drag, UI follows, and auto-generated CSS. You can also generate your own code, which comes JavaScript, CSS, and even at the backend, low-code generates .NET libraries. And even if you think something is missing and something extra you really like to do in the OutSystems, which isn't there, but you can do that in the another platform called OutSystems Integration Studio, where you can build your own components using the .NET libraries. So yeah, so that's one widget can help you to do so many things. So this is what OutSystems, and it integrates easily with database, API, and any cloud services. It's not mandatory that you have your own database in OutSystems. You can have it. It is very easy, very handy. You can create your own tables, own architecture, infrastructure, the screens, the logics. But of course, you can, create your own DevOps if you want to do. Everything you can easily integrate with the OutSystems, very easy, and you can find so many widgets regarding Forge components regarding that, which will definitely help you to build your own enterprise level applications. So yeah, that is number two. The last point which I really emphasize is strong AI capabilities such as AI mentor. I really wish to present AI mentor here in today's tutorial, but for some reasons, not for some reasons, but actually I couldn't, because AI mentor is there's nothing free I can access of. So that's a paid version of the OutSystems, and but I can explain you what exactly AI mentor is. So OutSystems AI mentor, they recently launched a new one. So basically, what happens in the OutSystems, you just explain what exactly you want in the prompt, what like we do in the ChatGPT or other AI tools. You write a prompt, and what AI mentor will do, it creates a raw and ready to build app for you. For example, if I want to create an app, or maybe mobile, or maybe web application for my business, maybe cycle business, for example. So I can just write a command that I want this, a detailed command. What AI mentor will do, it will create a huge architecture, relevant screen, relevant database, and relevant, styling class as per your requirements, which will be reusable. You can add, remove anything from you if you wish to, but it basically reduces your, like, at least 60% of your efforts from the scratch. So this is what the AI mentor is. And yeah, it also suggests the code suggestions and each and everything. So yeah, that is the out system for you. So what's next? White matters. So this is basically the objective for today's tutorial. So data is everywhere, but insights are not. Maybe some of you might not agree on that, but since we all know data is the main thing in this world, actually. If we have the data, we can do anything. So the major thing which matters is the insights, basically. To we can manually do this, of course, by looking the insights of the charts, for example, to know what exactly going on with the data, that if sales are dropping, increasing, which month was anomaly, and what is causing some kind of these problems. So this is what we will be doing with the help of AI, SQL, and low-code systems to understand, react, and learn. So what I have done is, and we will be all seeing it in a couple of minutes, hopefully. So what I have used is AI, and plus I have created some SQL queries to basically aggregated a bunch of data, a complex advanced SQL query, which helps, of course. And then the low-code system, especially for the front end. However, my SQL also belongs to OutSystems. I'll show you. And then the low-code system to understand, to interpret the data, and show on the screen the modern, insights of the data. Right. So today, what we will do is we transform the dashboard into intelligent assistant. So the idea behind this was basically, since we basically deal with enterprise companies here in the UK. So what we do is our product is only for the enterprise purpose. For example, you have a fleet and you have at least, not at least, but you have maybe 10 EVs running in the UK on the business. And what it will benefit you is you will have the one card, the power card, basically. You can give you to your drivers. They can charge from their card in the public charging charge points. And then what you will gain is a complete insight of a dashboard, where you will see the list of charts, if I'm not wrong, maybe 9 or 10. And then not only in this, you will see the hierarchy of each and everything, your users, where your vehicle is being charged, and how much energy your driver has charged, each and everything, the spendings, the billing, each and everything in one single platform. So that is the beauty, what we provide to the customers. And one of the examples I took here, specific for this tutorial. So today's focus is a working smart analytics dashboard. I just explained what we'll be doing, and SQL-driven charts. As I mentioned, about 10 to 12 charts, but among that, I've been using only 4 charts. Of course, looking at the time, definitely I'll go further if required. And then integrated AI generation, of course. Here, for the AI generated AI insight generation, I have been using for the OpenAI APIs, which will be shown quickly, and a full data intelligence pipeline and concept you can use on any platform. This is just not you can do on the OutSystems only, but of course this is open. We can do whatever we want on that. So further, system architecture for this tutorial, what I have used is SQL. for the data aggregation. And here, when I start the demo, basically, I will also show you the OutSystems aggregates, because we have some aggregation available as well inside the OutSystems itself, where you can fetch, create, update your all CRUD operations basically in the aggregation. It's very smart as well, but not very efficient when it comes to the complex SQL queries. I know lots of databases are here, but SQL is one of the oldest platform we have for the data things, and I don't think anything can beat SQL at the end. So this is what I will be using today. And low-code for UI OutSystems and charts and integrate and interaction, sorry, and OpenAI insights, anomaly detection and summarization. What we will be doing is we will see a couple of charts, and on a click of a button, basically, you will see the response from the OpenAI that what's going on with the charts and any abnormality we have or anything like that. And yeah, of course, the client action, capture chart, JSON, yeah, data set and scenario. So here, what the scenario I have, I think, taken, which I explained in briefly, which is EV charging for enterprise fleets. Like I said earlier, that the dev data I will be using. Of course, this is not real, but yeah, it will be enough for the better, see. So, and data sessions, drivers, vehicle, network codes. So basically, the example I have taken here is, for example, your drivers has charged how many hours, how many energy, the total spending they have charged, and which vehicle is being charged, and on what network they have charged. So currently in UK, we provide more than 65,000 connectors here in the UK. One of the leading connectors we have in the UK, provide the public connectors. So the network name we will show, and the goal of the scenario is to understand patterns, anomalies, and inefficiencies. Okay, scenario, I mean, to continue, chart use. I have, like I mentioned, the number 4 charts, and starting with the charging history, basically. So here, what we will be showing is from a date range, from date to date, because you have lots of receipts in a single fleet. So here we will be taking an example from a single fleet to show the charging history. That means here, what we will be doing is we will be taking top 7 CPOs, charge point operators, where the driver charged most, and with respect to the date, from a given range of the date, and it will integrate by 3 ways. You will see the data coming as a day, every day. I mean, for example, from 1st March to 17th November, each day on the chart. And then you have an aggregation per week, like 1st March to 17th November, how many weeks, and week wise, aggregation of the data. And then the month, from 1st March, like March, April, May, June, July, August, September, and November. So you will see the data of your drivers, basically, where the most network they have been charging, and yeah, this. And then spend energy by vehicle. This is one of the things, basically, that what kind of, I mean, which vehicle is being charged the most, basically. It's a similar kind of thing, but the data set, the superset is same. It is called driver charging receipt, a table which the data is coming from. It is just an aggregation that which vehicle is being charged the most. And spend energy by driver. For example, if you have a list of drivers, here we will be taking top 10 drivers who are charging the most. So basically interpret, and then the average driver cost per kilowatt hour. So that is very important, basically. This is one of the things we think. So just to explain the scenario here. So what is happening is you have top 10 drivers, right? For example, top 10 drivers, they have spent in a given date range, £100, £200, £50. So that is the range of the total cost they have spent in a given range. But average driver cost per kilowatt hour is, for example, in the UK currently, at normal, 1 kilowatt hour per hour is you roughly 60 pence per kilowatt hour to 89 90 kilowatt per hour, depending on the charger type. we have rapid chargers, we have slow chargers depending on the rate, but this is the average I have taken. So basically, this chart will show basically the average kilowatt per hour. Since the rate, for example, is 60 kilowatt per hour of a charge point, but a driver is costing average 2.5 pound per kilowatt hour. Why? Because probably the other costs are involved with that chargers. For example, overstay fees. What exactly overstay fees is? Basically when you go for your EV to charge, basically there's a cost called overstay fees. Basically, when the charge point applies that to you, for example, your car has finished charging for maybe half an hour, 40 minutes, but your vehicle is still parked for more than 10 hours. So per hour you have an overstay fees as well, which applies to your charger. That basically increases your average driver cost basically per kilowatt hour, which is very insightful for a fleet manager to know that who is making the cheapest chargers, cheapest who is doing the cheapest charging, and who is doing the most expensive charging. So this is one of the very good insights we'll be knowing. And yeah, here we have SQL system architecture, SQL for the architecture, low code for charts, OpenAI. I think we have already talked about it. So yeah, this is what we will be doing. Great. So I would love to take you through the other things now here. Sorry. Good. So here in this session, I think I'll quickly demo you. I mean, not quickly exactly, but in detail, and then we can go through the technical aspect of how did we build that. So let's begin with that. Great. So this is what we have here. Since you can see my screen, this is the dashboard, a small dashboard I have built. One of the examples I have taken, as I mentioned earlier. What we have here inside, we have a date range. Basically, this is a default date range of a 1 month period. We can change it definitely. And here, for example, I changed it to June 1st to the current date. I'll be getting so many days here. So that basically what's showing us, starting from the top. It has total 151 charges. Total cost, including VAT, is 42 pound. Since that's the dev data, so I don't think it's a very good thing to show. If that was a production data, it would have been very high. And this is the average spend charge, including VAT, in the given date range. So what we have is here, we have the data aggregation by day, week, and month. So that is a day. Here in this series of x-axis, what we have is the some number of the charge point operators used in this date range. For example, here MFG ePower, Power Simulator, EO, Smart Charge, and Source. These are all the dev data, so it doesn't really exist all of them, but maybe some of them. So sorry, so that is the charge point operator was used in this data. Number one, that is called charging history, what we do, and it has aggregation by week. So in this rate range, we have how these weeks available, and this shows first day of the week, Monday, 1st June, then 8th June. This is what we have the aggregation, that in a particular week, how much spending had happened in the charging sessions. So and then we have month aggregation. Here basically we show June, and June 25, 0 pound, nothing happened. For example, July, 5 pound happened. August 2025, 23 pound happened, and so on. September, October, and November. This is the aggregation of month in this app operators. This is the top operators, and yeah, this is what we have. And here in this axis, we are not showing all the operators, of course, otherwise it will look as ugly as it could be. So what we are showing is here 7 top CPUs here, like 7 top CPUs as with respect to the charging amount or energy amount, and then the eighth source is the others basically. For example, 7 top 10, and then we have the others column, which basically gives you the insights that what kind of energy and where exactly your drivers have been charging so far. So that is what we have here. And here we have charging cost by vehicle. This is another aggregation that among these date range, these are the vehicles plate number we have basically to differentiate that which vehicle is being charged, how much total amount here. And this is charging cost by driver. Basically, we have shown roughly top 30 charge drivers here, that how many them are charging, what percentage of that here in this chart. For example, Pedro Costa charging 41% of it. Why not others? So that is, that is something we can see. In naked eyes, that what's happening. Just a visualization of the data. And then we have these two important things, which I mentioned earlier as well, which is popular drivers. That means who are your top 10 drivers spending the most. Here, starting from the top, he is spending 17 pound and to the 31p at the end. So that is the top 10 drivers basically in a rate range. They are charging the most. And here the most good part is average driver cost. For example, here Marcio, if he is here, see, he is, I think, eighth position here in the top drivers, 50p per kilowatt. 50p he has total charge, but he has been charging the most expensive one. Why? Because here there are some other things are mentioned, that they could be charging. Why this is average kilowatt, since all they are 15p kilowatt hour, for example, and he is charging 60p kilowatt hour. But we can see it nicely that it is why this is expensive. But it is always good to know why exactly it is happening. So this is what we have here, and then this button, get AI insights, basically. So let's try that now. And we have to wait for a couple of seconds maybe, and let's AI insights all these 4 charts and give us a better response, that what exactly going wrong here. He can and the AI can explain the charts behavior, how is it happening, and any anomaly he can find. There you go, he's done. So here we have a couple of wording, which I can zoom in a little bit if that can help. So that is the analysis of the AI, what he thinks. Charging history. The dataset captures individual charging session over several months. Good. MFGE power simulator, and smart charge are the primary series involved. That's true. What we have seen, like 3 or 4 series. And the power simulator notably dominates in terms of energy consumption and large kilowatt hours in August and October. So that is also a question, that why your driver is charging on only specific charge points. There could be some reasons of that. Maybe those charge points are cheaper, maybe cars are expensive. So it's always good to know that. And power simulator notably dominates in terms of energy consumption with large kilowatt hours in August and October. So if we see, yes, August and October, this is all power simulator. Here we can see the tooltip as well, which basically shows which charge point operator dominating the charging curve. And here again, the power simulator. And good to see that. And costs correlate with energy levels, but show minor discrepancies in July, where costs appear slightly lower for the energy consumed under power simulator. So basically, that's what is happening. AI finds some discrepancies in July where costs appear slightly lower for energy. And number 2 is a spend energy by vehicles. This is the chart the AI is talking about. And yeah, here what it says, vehicles are labeled with IDs, like this is a plate number which it calls IDs, has highest energy usage at 14 kilowatt hour, but significantly lower cost compared to this vehicle with 83.74 kilowatt hours and 12.56 cost suggestion, different charging tariffs or efficiency cost management. So this is something is happening that one vehicle is charging that much one and the other vehicle charging that much one. Because if I'm a fleet manager, so I would always want my drivers do the cheapest charging ever, and to find any anomalies, anything, I can ask them if any kind of fraud is not happening with the chargings. So this is the insights of the chart number 2. Then we have spent energy by driver. Federal Costa is the highest energy consumption driver with 225.5 kilowatt hour, followed by AP with 73 kilowatt hours. This is what we have seen. Costs generally align with energy usage, though some anomalies exist, like Atharva is relatively low cost for higher energy consumption than some other lower energy drivers. So this is exactly what we recently talked about, that this guy is doing that much, but this is comparatively doing lower. So I can ask you exactly, because you have a same business, right? You can drive maybe same amount of miles, maybe larger amount of miles, but you can interrogate with your driver that what exactly going on, why this man is doing that much charging and you are doing that much charging. And then we have average driver cost per kilowatt hour. This dataset calculates average metrics from 151 receipts. So I think he is talking about this chargers. So that is the receipts we have, and the dataset calculates average metric from the average cost per is 27,876p, and the average total energy per receipt is 2.58 kilowatt hour, providing a general benchmark for evaluating individual charging session against a fleet. So currently, if we see this data set, it is usually same 15p, 15p, 15p. That's unfortunate. I did not have the better data here in the dev, but it's completely different. If it could be fluctuation, like one has 79p, one has 1 pound, one has 50p. So there are high possibilities you can have so many different average cost per kilowatt hour. So this is what anomalies, cost drivers, and operation inefficiencies found by AI. There he found cost disparity, basically. So the vehicle number, low cost despite high energy use point, that could be a data problem as well, to either a beneficial charging plan or unreported cost, basically. So it could happen that something is not really good, could be some data problem, or maybe the vehicle is being charged more, but it has been written, or it has been assigned a lower value. Why? Low utilization vehicle like this and blah have negligible utilization, which may indicate redundancy or possibilities to consolidate fleet, basically. And this principal cost, some drivers incur higher cost per energy unit, which could imply inefficient driving habits or remarked high tariff charging stations. This is one of the very important points, basically, because since we all know, even diesel and EV has a similar principle, depending on your drive mode, that how do you drive, how efficient do you drive. If you drive more efficiently, you will consume a very less power of, very less energy. And if you if you put a foot high on the accelerator, your battery will drain, of course, relatively faster than the normal one. So that is very important. Why a vehicle, for example, a vehicle has a 50 kilowatt hour battery, and it discharge, and it gives you only 3 kilowatt per hour per mile, which is a bad economy, which I think of. So that's a questionable thing, that why it is draining much faster than it could have done. Then AI also do some recommendations, that what kind of things you can apply to strengthen your things. Number one, audit charging plans. Conduct a thorough review of charging agreements to optimize tariffs, especially for high usage patterns like power simulator sessions. This is something we have seen upper, that power stimulator is dominating in the charging history. That why only one CPU is being charged. Two possibilities I talked about could be very uh, cheap charging, or could be something fishy is happening. So this is something we have to optimize. Fleet manager can do with that. And then we have fleet and driver alignment, continuously optimize driver vehicle pairings based on historical efficiency data to maximize energy efficiency and reduce cost. So this is again, it's very this is something we talked about earlier as well, about optimization, that how efficient and how good you drive to save as much energy for you, for your company, and for the world, of course. And cost evaluation, implement automated monitoring system for real-time decision making, promoting charging during lower tariff periods. This is very important, because usually what is happening is, as sometimes the charge points in the public charge point basically gives you lower tariffs in nights probably as compared to days. This is what we usually do in here in the UK. If you consume the electricity here in your houses as well, it has the same principle, that you have a lower energy tariffs in the nights comparatively in the day. And the same goes here as well, here, to basically ask your drivers to go and at those times suitably to charge no, as cheap as they can. And then we have sustainability practices, promote energy efficient driving training for drivers for this appropriate cost to improve overall fleet covers and effectiveness. This is exactly what we talked, that must train your drivers and must investigate your drivers, what's going wrong and why the energy is being charged, at a expensive rates and something like that. So that is the AI insights, which is amazing. One can use and one can see the detailed insights and get the recommendations from AI and try to implement and try to solve the real problems what we have. So yeah, that is the demo we have on this at the moment. And yeah, the next what we will be doing is we will be going through the out systems, and I'll try to show how exactly I mean did that with the help of SQL queries and with the help of OpenAI APIs. So let's begin with that. That's a part here, and I can drag my screen here. Cool. So I think before starting everything else, as I spoke about low code, as I spoke about out systems, I would love to give you a brief demo. How does out systems look like, and how we build it from the core. So this is something this infrastructure looks like of the out systems, where you can create your new application or install from Forge. We have a Forge component in the out system. Many you can find many helpful, many AI related things are happening in the Forge. You can install from there, or you can create your own new application. So here in normal, what you do is you create a new application and you get two questions, that do you want something from scratch, or you have already an app. So here in this case, and from scratch, and I do next. And if you remember, I talked about AI mentor as well, where you don't do this kind of steps. You just write your business strategy, business plan, everything, and our systems will create each and everything for you. So going forward, here we have these kind of types. You have what would you like to do? Reactive web app, a tablet app, and a phone app. And you have an external web portal. Reactive power is something belongs to me, and yeah. So usually what we do is, in general, either we create a web application or a mobile application. So that's the beauty of that. One system, one infrastructure, and can be used in both your mobile application and your dashboard. This is what exactly we do. So here, if I try to open next, give my name, for example, my project name, basically what we usually do in our traditional programming as well. And I name it as my tutorial, and I put some description as well. That is my demo, for example. And here, this is basically your theme. Basically, you can decide which color theme you like. You can definitely customize it as per your requirement, and you can also upload your own icon, which will show in the application itself. And yeah, you can create the app. That's it. And this is how it does it. Basically, you have to create your module. You can create as many as module you want, and I can for now create this module, and yeah, boom. So now the platform is ready for you. And here we have these kind of things. You have screen, blog, email, external site, and comment. So one thing, we start from the screen, and inside the screen, the overall architecture is already ready, and you have four important pieces of things you have in here. Processes, basically, I mean, it comes at the end. So I think I should go with the interface first. It creates your UI flows. Your screens can sit there. Your any blocks can sit here, and here you have I mean, usually your onboarded and pre-loaded things are already there. You can use maps, you can use OutSystems UI, basically. And that's a key thing to have. Basically, you have each and everything inside one single thing. And even if you don't find your thing, you can definitely make your own thing, as I said, through your custom code in the integration studio. Then that's the logic tab. That's the backbone. That's the main thing you have. And that's my thing, actually. This is what I work really. So here you can create your own server actions, your own client actions, and that is the integration of systems of offers. Integration with external systems, like you have, for example, Amazon Cloud Services, for example. Here you can create your own SOAP APIs, and this is you can create your own REST APIs. You can expose the REST APIs, you can consume the REST APIs. Both you can do, and both we do on regular basis with the EV charging infrastructure. And here you can also post your SAP, and this is your roles. Basically, you can build as many roles you can: anonymous, registered, admin, whatever you want. And these are the all exception handling, the error handling we have entirely here. Something goes wrong, some message, and yeah, boom. That's your data part. Very important, of course. Without data, can't do anything. That's your data point. Basically, what you do is you can create your these are the system created tables. For example, users, you want to create some users. That's a part you can do is. And these are the out systems charts, which the charts which I showed you earlier on the web browser. That was all out system chart. I didn't do integrated my own chart. I could have done that as well. It's relatively easy, we can do it. And then we have maps, and then out systems UIs. Basically, it's all UI part. And yeah, that's the structure parts. I'll show you these all things in the next app. So that is the brief explanation how our systems work in a demo. So start with our thing, basically what I did. So that's a screen exactly I created like I did now. I called it tutor, and I had so many roles on that. And this is the widget tree, which is very important. So that is the screen, and we have the layouts plan here: the header, breadcrumbs, title, actions, main content, and each and everything. You can put whatever you want to put inside the main content title. So the placeholders are already built, and you can put that. This is the part of the widgets you have, like container, conditions, list, and many other things. So here I put my all charts. I think I don't want to go to the charts in details. Like this is the column chart I had, and these are the basics, inputs. I pull the data from the SQL queries, and these are the four charts I had been using. And here you can create your own local variables to support your data. Of course, you have, I mean, as many local variables you can create to basically give you the insights. The data will put in the local variables. And then we have the aggregates. I'll show you one classic examples of aggregates and the data action. So these are the actions which I use. Number one is this. What I'm doing is I'm fetching my data for the charts from these actions. And I would love to go one of that. So this is basically, this is how it works, your server actions. It has a start and the end node. You can have only one start node, but many end nodes. And then you have a couple of things you can use into your server actions to perform that, what exactly your screen or your things can behave. So that is all data actions. I'm fetching the data from a external server action. So I can go with that as well very soon. And here we have SQL aggregate. This is the classic thing I really want to show you if we got some time. So we have so far. And here if condition, switch, for each loop, JSON, and so many things we use. So what's happening? I think I'll go with the SQL first. So that is the one of the important. One thing I want to show you, which in South systems, you have aggregate. This is the aggregate, and it does the similarly things, but in a visual way. For example, I can just a second. Yeah. So that is something you can do is 1 second. Sorry. Yeah, there you go. So this is what you can do here in the aggregate. Basically, if you have the data, your tables, you can put your tables here, and everything you can do visually. It will show you the sources of your tables, apply any filters you want, any source you want, and this is the test value to see your data dynamically. And here you can find your aggregation. And you can also, apply the basic SQL aggregation, like group by, count, sum, average, each and everything directly here. So I like this sum, average, max. It has a pre-built functions. You don't have to do much on that. Very easy and very handy. And it already optimizes query, but one thing to consider is it's just a system generated things, and it has a limitation. Likewise, every system has some limitation. At one point you have to go traditionally. There's no way other out. It can help your problems to solve like 85%, but it's still 15.5%. You can have to go somewhere else and find your solutions. So something was like that as well. The charts, especially the charging history chart I showed, was very complex when I was doing with this aggregate. I can show you this is the action what I did earlier to fetch that chart. So that is the aggregate. Another loop basically, and the idea is to gain top 6 CPUs, top 7 CPUs, which I mentioned you, and then another iteration, and again so many local list appends, and here again a for each, here another for each. So that was a very, very complex and slow things, because I have been iterating so many times. And the result, what was the result? That I was getting timeout errors, because usually the default timeout setup is 40 seconds, and that is ideal. Your server should not wait more than 40 seconds for the users. Otherwise, it will be really, really problem and bad for the end users. So this is what happening. And then when I come into the SQL, so as you saw, all sorry not this, but all this, lots of things, it was doing the same thing, but in a very, very inefficient way. This is what we never wanted. Now what came into being? One SQL query, and do all the things. It's very easy. I can go line by line how exactly I identified and handle the things. Since the data tables are already present here in our data tab, and these are the data we have been working on, so many tables. But here for this particular example, we are using only one table, basically, mainly. So starting with that, we are completing this in the 4 basic steps. Number one, it was, as I said earlier, that we have a top 7 CPUs we want to do. So this is basically to select top 7 charge point operator names in the series x-axis, which we showed as a CPU name, and then sum the final cost, including VAT, basically to show on the y-axis the total sum of those metrics from this. If that is not really visible, I can do something like this. Maybe this could help. So that is top 7 CPUs from direct switching receipt as I asked. This is the only one data set we were using, and with a condition where start time, like the condition I showed you on the front end, that we have a date range from and to, because we have lots of receipts. And the example I showed you on the front end was only for one fleet. It didn't include all the fleets. It was a one test fleet which I showed for my demo, and this is what we do. And fleet ID is equal to fleet ID. Basically, this is the main fleet ID we were showing on the front end, and that's the total, I mean, filters what we have been using here. And then step 2, that's the weekly CPU aggregation. That in a start in a range, we have day range, week, and then the month. This is what we built for the thing, weekly CPU as data date minus that is the part of your parameters of from date and to date. So minus date part, weekday, DCR charging receipt, start date time plus 1, and cast, because the database gives you date and time format. So this is the casting, basically to convert the date time to date, because we didn't want a time over there. And that's as normal conditions. If that is null, so that is for the others. And if you see the others, it was basically to sort them out. Basically, what happens sometimes, others, ideally in our system, it should come at the last in the series name and the pass in the charge point operator names. However, the sorting was done with respect to the date, and if we put the date respective, then the others can shift depending on the volume of the others have. It could appear in the last, it could appear in the middle, it could appear in the front. So for that reasons, we initially did the others, so that by the if we sort it in the series name by Z to A, so it can go to the end. So that was the idea. We put the others as CPU name, and that's a normal thing. If your energy 0, then as total energy and total cost. So these are the two things we have been doing, and that is the joins of top CPUs on charge point operator name. And the same condition I showed you, the intervals from start date to end date again for the aggregation. And then group by date. That is very important, because we are having the columns of per week wise. So that is basically the aggregation of weeks in the time intervals. And then step 3, calendar of weeks. So that was very important, basically, since you can initially what I was doing is presenting it as week 1, week 2, week 3 in a date range. But then we had a requirement that we should only show the first day, which is Monday. And OutSystems basically has a default thing. Basically, the start of the week is Sunday regarding the OutSystems, but we wanted to as Monday. So this is what we did for the select plus 1, so that Sunday is go to the Monday, and then union all with the week calendar. And step 4 was the fallback CPU. Basically, what was happening is some CPU did not have some cost. We were having some problems. And then weekly CPU to align those CPU in a series, so others and the other CPUs aligns very well, and they basically do the CPU things, and that was the final output. Form date is null, and yeah, this is the concatenation. Basically, that is the tooltip. What we show on the hover of the column, it shows you the total cost, total energy, dates. So that is the concatenation of the tooltip, basically. And yeah, that was that was it. I showed you one of the examples with lots of iterations, and one with a single query. It basically saves time, saves energy, and optimize at least 10x extra. So that is the SQL query which I used to showcase my in my demo in the chart. Cool. So the other thing I used in the demo was the API on the button click. What exactly the responses was coming from was from here. So here I consumed a REST API here. That was the action I used basically. And before explaining this action here, I would love to go into the API first. That's the API I was using. Sorry. That was the, we have two APIs we could have used. One is the generation API, that is the open API is completion with the images. And yeah, this is the API where what we were using is API openapi.com and completions. And it has, of course, a request body and the response which we have to give, the main authorization, a bearer token, open organization, open AI project. So I don't know if I have cleared it very well, but consuming and creating the APIs in our systems is very, very handy as compared to the traditional programming by writing, lots of code. And to be very honest, I personally tried very less doing the traditional working because since 3 years I have been doing that, and I find it very easy and handy to and compared to the traditional programming. What you have to do is you have the post methods here. Like we all know that these are get, post, put, delete, and patch. We have 5 methods, and that's the post method because we are getting some response from the OpenAI. We did post, and this is the API we had, and that's it. And here we have the inputs like authorization, AI organization. These are some mandatory and some optional inputs we have like that, and a request parameter and the response here. And then to consume this REST API, we created a new server action, basically that gives us ready to go server action, basically. So we can call that server action on any button click or anything that gives us the right information. Here, one thing you could see is here we have in a request model, basically in the API itself, but this is something we don't want. And one more thing I would like to share is the request parameter here. So in our systems, basically, when you deal with those APIs, you always go in the structures. This is what we do. The JSON things comes in a structure. You have to create your own structure. And of course, depending on the API documentation, what structure you want in the way, the data types, how do you define? Here, you create a structure, for example, here. Maybe I can say open API. Then it asks you to do some attributes, for example, here. And we can match those outputs from here, like model, like I have model. And here, this is the most important part, is name in JSON. This is very important because it has to match with the documentation, like what kind of response you will get from the endpoint. If it doesn't match, you will definitely get error. So it has to match for the model, and so far and so on. I'll keep doing my structure with Control N and keeping the new attributes, and I have to explain it away. And here you can also put a data type. So sorry, that's the name of the attribute. Here you put some description, that is the model name. And then label we have is model. You can put your own label if required, not. And then the data type, you have all the basic data type depending on your structure. What you want is text, integer, long integer, decimal, boolean, data type, date time, phone number, and list or record. It's very easy to maintain here the structure. And other entity, basically you can also provide some entity. For example, usually there's a data type called enum basically. So enums, it means it's a static entity. It means the documentation says at least 4 to 5 values. They will at least one of them they will send us through the API. And to handle those, what we create is static entities. That is the one of the most used in the structure. And if I create okay, there you go, not this, I don't want an entity, and but I can create my own table, my static entity. As I mentioned that if your documentation is receiving some kind of enum data type, and then that enum can consist of fixed value of 12 or 15, that is my enum. And the idea of static entity is they can only be get, I mean, you cannot update it, you cannot change it. You have to provide some records, that your record name, it could be, for example, you have a response and it consists of months in the year, Jan to December. We all know Jan to December can never change. Either you will get January or you get Feb, at least one of them. So this is what we can put as a record, that okay, Jan, Feb, March, April, May, and we can assign directly the ID of this enum. Sorry, my typo is enum. So this is something you can create very easily. And then I don't show the that entity. That's your main tables basically. Your system has, I mean, what kind of tables you want to create. That's an optional thing, of course, to doing in our system. If you don't want it, you can have your own data structure, your own tables somewhere else, and you can definitely integrate those tables directly through APIs or through other things. So yeah, that is how we create these tables. I don't want them, and I can delete it. Good. So the other thing which we were talking about was the structure. Basically, it holds all the request and response structure. Basically, see, this all are coming from this. That's a response. What OpenAI gives is ID, object, created, model, system interpreter, and here inside the structure we can have another structure. For example, we have a structure of the response, and here we have the structure inside the record. We can have a list inside a record. So here you can put your own as many structure, and you can consume in the main request or response, structure, either record type or list type. As I mentioned here, data type you can create. For example, it is a list of records. Good, it's done, right? And in case if you wish to have a record type of that, for example, I want to consume a course item as one of the records here, and I do this, add attribute, and name may be same if that gives, yeah. So now this is called the record type of that. It can, and the values we can assign it from here automatically. So this is the structure, is your JSON structure lives in that way. And as I mentioned earlier, this is very important that your name of JSON should definitely match, otherwise you'll get errors. So this is what we were talking about. I had already consumed this API for the testing purpose. You can also test directly from here, but I usually prefer Postman, like every other developer do for the testing of the APIs. So yeah, you can also check or test your APIs here as well directly to introduce. And then yeah, this is what the response we'll get. Cool. So that is the REST API what we have consumed. As I spoke earlier, that I have created another action here to basically consume that one. And since this API has a request model, I really don't want my other developers to match those request models uh, separately. So what I have done is basically in this server action, I'm basically appending this whatever the list I can get and try to make them in the input. For example, I have a list of images here. Okay, list of images is here. List of images, I have created the input here. Yeah, list binaries. This is a local variable I created, which I'll be assigning to this input. Basically, it content list. That means a binary list, basically, and it can I mean, in the chat GPT, of course, you can put your own images to interpret anything you want. So that is a appending of the list, and to all binary, just a normal condition. If that matches, okay, otherwise not. That's the list of appending of this list, trying to, I mean, match as much data as I can to reduce the number of inputs a user, not a user, but a developer can try to put in the server action. This is what we have, base 64.2, and we have lots of functions here. Here, this is the expression. When you assign something, you have lots of things here. You either assign from your local inputs, variables, outputs, or you can directly access your entities, but only static entities at this point. And you have lots of user functions, that these are the systems function. For example, list distinct, list input. And you have lots of built-in functions you can use. For example, your response is giving date to time, but you want to convert that to the date. So here you have match function. It gives every information that what kind of function is that. You can entirely use directly into your expression and assign the value. Node, power and lots of others, such as numeric, text. This is for the concatenation, encode, and encode JavaScript is one of the great things we can have. There are lots of functions which you can easily use to trim, start, and especially date and time. Lots of date and time functions which are very useful, you can put. So yeah, that are the things you can have it. And yeah, and this is the list binaries, and you will list append. Then when you consume your REST API, which is here into this section, it will definitely ask you a couple of things. These are your authorization bearer token. You can directly assign it here. I can show you the token here, but yeah, this is the organization. This is again an ID which OpenAI asks you. And then OpenAI project. This is a non-mandatory thing basically. We can have a description here as well. And then this is the request model I was talking about, and I have just opened it and trying to match the data directly here rather than putting another input which I have to consume in other module. So GPT Pro, these are the types basically I have put, and yeah, list and list of images. So these are the APIs I have used, and the same server action in my project I have been using on this button here. Here, get AI insights. This is a button. This is a loading button. Basically, whenever things are loading, it will keep giving you the loaders as soon as the whole flow is complete. This is the action I have used. I have give a prompt here, which I'll show you how did I match that prompt, which was shown on that. And this is the optional thing basically, binary. If you really want to attach some kind of image, one thing I had been trying to do was to create the image of the chart, but I couldn't do that because OutSystems chart doesn't have any handler basically on initialize. So with the help of JavaScript, I was trying to do, but couldn't do for some reasons. And AI response basically, this is the output of the local variable I have taken from this. Whatever the response I have been given, I can assign to this and show to the screen which I showed you. And here one thing is that JSON response. Basically, this is the optional thing. This basically attribute to define if the response is expected in JSON format. That means any response you really want to ask from the OpenAI API from the JSON itself, so you can directly use that and store in your database as well, which is amazing. And yeah, that is the flow, and this is what we did. And then the other thing we did here, these are the, I think in the initially I explained in briefly, these are the data actions. I fetched my data for the charts, like 4 5 charts here. These are the 3 datas. So what I did, this is the calculation you could see here. These are the calculations of this. This is the different server action I created. And then for there's a switch basically for the day, month, and week, which you have seen. And for example, if I click the week, it will give me the only queries response from the week aggregation. And then what I did, I just serialized the JSON basically. And here in this, I created the output parameter inside charging history basically, and it can change, right? Regarding, I mean, with respect to the input we have given on the click of the button. So that is the serialization. And I have just, this is the data list I had in from my query, and I just serialized it in a JSON. And this JSON I gave to this output parameter, and that's it. That's the main thing I did for the JSON. And then the query I did here, when I call this prompt, I will show you how did I prompt. This is the important thing. The main prompt to the API I given. I can increase a little bit here. Yeah, perfect. So what I did is I tried to concatenate all the JSONs from like different server calls, 5 JSONs into one JSON collectively, and try to command what we do in the ChatGPT usually or other platform, a prompt. And I want this. This is a JSON. Again another JSON. Again another JSON. And again another JSON. 5 JSONs together. Not 5, but 4 JSON. And yeah, 4 JSONs together. And then the prompt I written: you are AB Fleet Analytics Assistant. Analyze the 4 datasets provided. Charging history, spend energy. This is the name of the all the charts I have given. And with a new line, I given the instruction that analyze each dataset individually, provide cross-chart platform and patterns, and highlight anomalies, cost drivers, and operational inefficiencies, and give concise, actionable recommendations for fleet management. What we had seen at the end of the response of the AI. So this is the command, this is the prompt I got ready with the concatenation and gave to this API here as a variable of the prompt. And yeah, that's it. And I copied the whatever the response came from this API to this, and showed this variable at the end here as an expression as a AI response, if you can see that. So yeah. So yeah, this is exactly I try to accommodate the things to get the insights in that. And we could have worked in many other charts, but yeah, I found this as the best. And that's it from my side. Thank you very much for listening to me. Yeah, any open for any questions? Yeah, any questions or remarks?
Okay, I would like to ask again if anyone has any questions before we wrap up this presentation. So if nobody has any questions, I would like to thank Anil for his amazing tutorial.
Thank
and
you
we
so
have
much.
one more session to go, and it's starting at 15:15. And thank you, Anil, again for your amazing
Thank you so much.
presentation.
Yes. Bye.
Bye.